Now I'd like to introduce Dr. Hrvoje Stancic. Hrvoje is Vice Dean for Organization and Development and full professor at the Faculty of Humanities and Social Sciences at the University of Zagreb in Croatia, where he teaches in the Department of Information and Communication Sciences at the undergraduate, graduate, and postgraduate levels. He has been chair of Archival and Documentation Sciences at the same department since 2008. In the context of the fourth InterPARES project, InterPARES Trust, prior to this one, he was director of the European research team where he had a blockchain-related research study. At the Croatian Standards Institute, he is president of the Mirror Technical Committee for Development of ISO TC 307 blockchain and distributed ledger technologies standard. In October 2021, he was awarded a bronze medal at the 19th International Innovation Exhibition for his innovation Trust Chain, a system of preservation of trustworthiness of digitally signed documents. In 2002, he was awarded a silver medal at the 19th International Innovation Exhibition for his innovation blockchain-based diploma authentication system. He's the editor of the book Trust and Records in an Open Digital Environment, which was published in 2021. Welcome, Hrvoje.
Thank you, Rain. Good afternoon, dear colleagues. I will be presenting today on a topic AI as a service for archives. So this is the brief outline of my presentation. So I'll give the introduction, tell you a little bit about the initial survey that actually started the AI model training that I will be presenting later on, and then I will conclude. So first of all, to remind us all that the aim of this study was to, and still is, to identify critical archival challenges for implementation by AI technologies in the context of digital records, but we were also focusing on preservation of digital records. And once we learn about the archival challenges, then to create an AI model to address those critical archival challenges. So in order to detect what those are, we conducted an online and a follow-up in-person survey from March 2022 until January 2023. The survey was done in 3 languages, in English, Spanish, and Portuguese. We received 106 responses from respondents from 27 countries, and those respondents actually identified 30 repetitive and or time-consuming tasks. The task that was the highest ranked was adding, gathering, and extracting metadata. So that became actually our focus. But also, I would like to share the following results. This is the result to the question, to which group of activities the identified processes which can be additionally improved by AI-related technology best relate to. And these were the answers. So you can see that the highest ranked was, again, arrangement and description. So this also prompted us to continue our work in the area of description of, in this case, of a collection of archival images. We are following the typical life cycle of machine learning system development, and these are steps 1 to 6. I will be going briefly through each and every one of them. But in our research, and when I say our, I mean the collectiveness of InterPARES AI colleagues, we also came to realization of the importance of paradata. And that is why we are adding the 7th step to this model, although one might also argue that this step of creating paradata should be step number 1, or the step that is going to be there in each and every of the 6 steps of development. because we want to describe what we are doing so that later on anyone could understand what has been done and how an AI model was created. So I'll just briefly walk you through all the 7 steps that we have done or we are planning to do, because we are still not done. So first of all, the step number 1, data collection. In order to get a reliable set of data, we established cooperation with state archives in Osijek in Croatia, which provided us an AI training set. Excuse me. This is the collection of set outdoor and indoor portraits. The collection was 1,417 images, from which we extracted only the front pages of those digitized portraits and used them to train our AI model. The collection is from 1870s up to the beginning of the 20th century, and the image collection is divided into 9 categories that you can see on this slide. And what was really important was that we, alongside with the digitized images, we received the description of those images, and that description was done by a professional archivist. We used those descriptions for training AI model. This is the example of one of the of a description set of an image. Of course, we didn't use all descriptions to train our AI model. We used only those shown in blue, and this is because the State Archives in Osijek, for example, more than often got some requests about the fashion that was the fashion items that were relevant for that period, so that someone who is possibly creating a fashion show could be influenced by those. Of course, they were supposed to previously manually browse through an image collection in order to get those items. So we focused on that. Of course, we got the images and we got the description, but the format in which we got the description, the Excel file, was not ideal for AI model training. We needed to prepare that. So we extracted first and foremost the implicit data. Is it female or male person, the age or the place, is it outdoor or indoor? And also the explicit data extraction was in place, and that was, by this I mean that the description that was in one Excel cell, we needed to extract into different cells, and then to sort alphabetically, and then to eliminate duplicates, and so on. So once we created a unique set of unique labels, 130 and 5, I think, that was the data set, the labels that we actually were using for development of our AI model. As you can see here in this example, the term mustache in Croatian language, of course, description was mentioned more than once, so that's why we needed to create a unique set of labels. In terms of data preparation, so once we got our initial descriptors right, we did a comparative analysis of 2 different image annotation solutions, and we compared them in the context of their precision and speed of possible annotation by humans. We used make sense solution and any labeling solution. So in terms of precision, any labeling solution was much more precise in automatically detecting borders of a certain object that we wanted to annotate. Make Sense used rectangular approach, so it was more often than not we needed to overlap rectangulars one over the other, which created less precision. Of course, in terms of speed, Make Sense was the solution that we were able to create results in a much faster way, but with less precision. Also, I would like to point out that the any labeling solution used artificial intelligence internally to be able to detect the borders of objects. So basically, we are using AI solution in the process of training another AI solution, right? And in that comparison, in that comparative analysis, we also detected some annotation challenges. So you can see here the two opposing examples. One on the left-hand side was the image with easily detectable object borders. If you think of, for example, head, it is clear where the borders of a head are. And on the right-hand side, if you think of the borders of a suit, then a person suit is somehow blurred or blended with the background, so it was not easy to detect the border of that object, so to say. Another set of challenges were the group portraits, where there are a lot of objects to detect borders of. So in terms of dresses or some other objects like a dog, you can see, for example, a dog here, and so on. And also we recognize some challenges with the low resolution images, because also border of the objects was not easy to detect. For that purpose, we possibly will be testing some image or resolution upscaling solutions, but we will see whether that will provide us with some better results or not. And also, in terms of annotation challenges, what can you do when an image is faded or damaged? So this also provided some hiccups in the process of annotation. Once we prepared the data, so we annotated certain objects. That means that we said, okay, this is a flower, this is a hat, this is a tie, and so on. We provided that annotated image set to the AI training solution. And for that, we used PyTorch and YOLO 5 utilities. PyTorch is an open source machine learning framework, and YOLO is a model using which was created there, so you have to recreate it. And in terms of local environment, it is much slower, but you retain the model to yourself. So there are both positive and negative sides to both of that. So we were annotating images in order to tell the AI model development or training environment, how does a head looks like, how does a tie looks like in many different situations, viewed from many different angles and from many different types of heads, if you consider that as well. And that is how the model learns from that. So internally, from the set of images we pushed towards the AI model training environment, internally, that model training environment divides the set into a training set and validation set, because once it trains itself using different stages or epochs, then it validates internally how well it performed or did not perform, right? So that's why it is needed to have it needs to have this set divided into training and validation set. And then we train the model. Depending on amount of images, depending on the resolution of images, depending on types of labels that you want to train a model on, it would take a shorter or longer time. And of course, depending on the type of equipment that you are using as well. We did that in a initial training testing, just during the time when we wanted to get our process right. And now we want to scale up, and that's why we obtained access to a server at the University Computing Center in Zagreb, which is a virtual machine on a computer center, and they have much better equipment used for training AI than we have locally on our computer, and it is comparable to some other online solutions. And then once we created our model, which I remind you internally use some images to train on and to validate on, then once it was trained, we tried to figure out in the next step of model evaluation how good it is. And that meant that we trained it on the images from the same collection, but those we left behind, so to say, and we didn't use in the initial model training. Just to see, okay, these are the images from the same collection, from the same period, from the same archives, how well the model performs. And then we also tested it against images from other available collections, from the web, and finally on our own photos of historic images. So the model was performing well in recognition of the trained model on unlabeled images. Of course, it was never 100% correct, but as you can see from these examples, of course, the labels are in Croatian language, but could be easily translated to some other languages as well. The numerical information here, 0.7576 means 75% is the model sure that this is a mustache, address, suit, or something else. But also take a look. But of course, this is wrong. This is not address, so we didn't get fully correct results. But if someone was looking at an image showing male suits, it would get this image, although it may wrongly recognize this as a dress, right? But this is also important to mention that here we have a tie, and it is quite a small object. And I'm pretty sure that if someone was manually browsing through the images and trying to identify a tie in this image, it would never catch that, right? So this is a positive side of our model as well. And then another source which was not part of the initial set of images. This image is from State Archives in Zagreb, so not part of the initial collection. And it recognized persons in this image. And also this is a my photo, a mobile phone made photo from when we were on the last plenary in Honolulu. We stayed at Sheraton Princess Kauliani Hotel, and there was a wallpaper at the reception. And this is on the left-hand side the wallpaper. I took a photo of that and pushed that image through our AI model, and I got the result that this was address 66% sure, and it didn't catch the hat here, okay? And this is address here as well, but I didn't enlarge that one. So this is a completely, not even image scanned professionally, but just made a photo by mobile phone. And then the fifth stage is model post-processing. So since the model is what it is trained at a certain point of time, then you cannot add some more images in real time to make it better. If you decide to add more images to make it more precise, then you have to retrain it again, right? How can we do that if we have rather small image set collection? We could, for example, slightly rotate image to the left, slightly rotate to the right, and then re-annotate and retrain on those images plus the initial set of images. We could, for example, do resolution variations and so on. We could also use image resolution upscaling solutions and so on. So if we decide to do that, we might get in the end an AI model which is a little bit better using this, let's call that a synthetic set of data, additional images, and we might think of that as an option if needed. And then a model deployment. This is still ahead of us. We want to, once the model is perfected, so to say, we want to put it on a server so that other archives having similar set of images or collections, but not annotated, use our model to get annotations for those images. And then we would also like to do a comparative analysis of how well does our AI model trained on archival images perform in comparison with some general models for image annotations. We still don't know whether our model will perform better. If that is so, then we could argue that we have created an AI model, let's call that, by the archivists for the archival profession, right? And this is something that we should be aiming at. Along all this, we would also like to create, and we will create, how-to set of documents so that any other archivist could replicate what we have done in terms of technology and in terms of solutions and in terms of steps performed to achieve that. And of course, I mentioned that at the beginning of my presentation, pair data aspect is really important. So if we want to create what we might call explainable AI, although it's not going to be fully explainable because we don't know how the model actually reaches a decision, but we will know almost everything that we think it is important to know. So how large was the initial collection? Where did it came from? Was the model allowed to perform on that particular set of images? Who did the initial descriptions? It was a professional archivist. It was not, for example, a crowdsourcing project, and so on. Of course, this also means that future users will know how this AI model works, what it can be used for, and what it cannot be used for. So, for example, this model cannot be used for identification of persons, so who is who in the image, because it was not trained to do so, right? So it's not used for that. And also, we would like to add some technical information to Paradata, because if this model is to be preserved for the long period of time, this might also be important for the long-term preservation activities for future emulations on some future environments, so that anyone in the future will be able to use the model on maybe some other future computer environments not existing today. To conclude, with this set of activities, we would like to go a little bit closer to the concept of AI as a service for archivists, for archives, as possible, so that we relieve our colleagues' archives from some repetitive tasks of manual labeling of image collections. So we are aiming at creating a product to be easily used by an average archivist, and also develop, as I said, guidance on how to replicate this training process on some other collections. Thank you very much. And if you have any questions, and you do, 1, 2, 3.
Just real quick, Richard. When you talk about AI as a service, I always think about price, cost. Like, are you thinking about offering this freely available, freely accessible, freely usable?
Well, I like to think one step at a time. So first aim is to have it done in a way that it can be accessed as a service. Later on, we could discuss if InterPARES is going to adopt this in some future subscription model or whatever it is.
It's becoming a theme. Thank you.
We're going to be rich.
Jim, were you next? Hugo?
I'm not sure.
Good.
You were,
Okay, Jim.
You know that I'm very excited about this project. I think it's really creative, and I like that it's converging with Paradata study and things like that. What I hadn't considered was the point Jessica made, like using AI tools to generate contextual information. And I was wondering if that might be an interesting thing to explore. So I think you just used the recto, the image side, but the other side there might be handwritten, commentary, and we might be able to tell this seems to be the same hand for these 20 pictures.
Or even in the frame, I noticed when you talked about it, the frame had the photography company, right? And maybe they were similar companies did many different images. I wondered about that.
Right, I agree. I mean, at the opposite side, there is information about the studio, about the photographer, about the author, or the owner, which might be different. So there are multi-layerness to this exercise, so to say, right? So this is just the first step that we just wanted to see how to get it right in terms of process. But thank you for
totally good. It's just it's nice to see how these studies are starting to touch each other a bit. And a little bit. One further question, and that had to do with habit.
All right,
Hugo.
Hugo, and then you think about whether it comes back.
We'll get back to you.
It's 3 questions, but they are very short. The first is the service the querying, or does it include also the training? Like, could you actually use the service to train with your own set, or do you use a pre-trained model?
These would be 2 different things.
Okay.
So one thing would be, okay, this is a model, and I'm showing my images to the model and let it, get the description from.
Yeah.
The completely other thing would be having to have a setup, the environment setup, so that you could, train and annotate and do it everything yourself.
That would be neat.
Yeah, this would be much complicated.
Yeah, and well, it's a related question. The second one is about the money and the computation power. Do you need that much power to query? I don't think you do. Right?
No.
Once the model is trained, regular machine could have it.
Right.
And you right.
Right. Yeah. So we moved to a much more serious environment in order to get our model trained faster.
Okay, okay. And the last question I had is the resolution problem. Of course, the resolution of the original picture. If you scan in a higher resolution library, do you have an improvement?
No.
So it doesn't
So
see.
At some point, there's a limit, right?
there is a limit on the resolution of the original, so to say.
Yeah.
We tested that in a completely different use case, and this is the OCR use case. So we basically realized that by scanning it in a higher resolution, it also picks up information on the paper structure, and basically it confuses the OCR.
You don't want
So
that.
we got better OCR results on 300 dpi than on 600 dpi. And on 600 dpi you use more time to scan it, more
It's also more
space for storage,
Yeah.
and you are much slower, and achieve
Interesting.
results which are.
So there's an optimum for each kind of
That's right.
time period. You could have an optimum.
Yes.
scanning
This is a completely different study which my colleague Hrvoje was specially focusing on that in his PhD.
Okay. Thank you.
Have you remembered,
I
Joe,
have.
Jim?
It's from an ethical perspective, and it's with your last slide. It has to do what this tool can be used for, what it can't be used for. What I am starting to see as I read those kinds of statements is they say what this is for. They don't say what it's not for.
Sure.
Other than, should not be used for evil purposes, that sort of thing. But it's not specific. What I'm wondering is, for the question is, did you ever push anything like very recent photography in, like not 19th century costume and stuff like
We
that?
did, but I don't have the results here. It's a different set of results, but we also tested this to a video stream,
Okay.
and it also recognized persons from some other described set. So it could also be used for detecting elements in the videos, although it was trained for images.
Right. Thank you.
Thank you.
Thank you very much.